Antarctica, 190 million years ago. The region had a warm, humid climate with seasonal variations and high pollen levels, indicating a thermophilic environment. The absence of mud cracks suggests it wasn't distinctly dry, while the presence of worm-like organisms points to consistent year-round fluvial, alluvial, or lacustrine waters. Cryolophosaurus, a carnivorous theropod. Cryolophosaurus was a robust theropod and one of the largest dinosaurs of its era. Estimates suggest that a specimen could have measured between 20 and 23 feet in length and weighed between 770 and 1,000 pounds. However, in 2016, some paleontologists proposed a larger size estimate of approximately 25.3 feet and a weight of around 1,720 pounds. It is worth noting that the individual studied may have been a subadult, indicating that fully grown adults could have been even larger. Despite its slender build, Cryolophosaurus stands out as one of the largest known theropods from the early Jurassic period. Cryolophosaurus has been observed with ribs extending back to the neck area, leading to the hypothesis that this individual may have succumbed to asphyxiation due to these ribs. Nevertheless, it was determined that these remains were indeed part of the Cryolophosaurus specimen and not from a lodged prosauropod. Cryolophosaurus fossils have been found in the Hansen Formation in Antarctica. The term Cryolophosaurus originates from Greek, where it combines words meaning cold or frozen, reflecting its discovery in Antarctica, with auros meaning crest, and sauros meaning lizard. Therefore, it translates to cold crest lizard. Cranial display characteristics, exemplified by Cryolophosaurus, are logical in the context of social and gregarious species, where individuals can observe and understand signals related to sexual status. Some paleontologists have questioned traditional theories regarding the function of unusual cranial formations and postcranial armor in dinosaurs, suggesting that these features may not solely serve to attract mates, deter rivals within the group, or intimidate potential predators from other species. Sichuan Province, China, about 150 million years ago. This area features several small lakes, forests, and rivers, along with numerous grassy savanna-like environments and wet, boggy marshlands. It is also bordered by small temperate rainforests. Mamenchisaurus, a herbivorous sauropod. Mamenchisaurus is recognized from fairly well-preserved remains. Some specimens measured approximately 52 feet in length, featuring a neck that extended 21 feet. The estimated mass of Mamenchisaurus is around 8.68 short tons, determined through volumetric methods. One specimen includes a nearly intact skull, which contains 4 teeth in the premaxilla, 18 in the maxilla, and between 22 to 24 in the dentary. A distinctive characteristic of the skeleton is the wedge-shaped sacrum, which results in the sacrum and the base of the tail being elevated in relation to the rest of the vertebral column. The discussion surrounding the neck posture and feeding strategies of Mamenchisaurus remains a topic of debate among experts. Andreas Christian and his colleagues conducted an analysis of the neck structure of Mamenchisaurus, revealing that when positioned neutrally, the neck appeared nearly straight, exhibiting a slight upward curve at the base and a gentle downward curve towards the head. The base of the neck demonstrated considerable upward flexibility, while its downward flexibility was more restricted. Conversely, the area near the head showed enhanced downward flexibility but limited upward movement. In the midsection, there was significant downward flexibility, leading the researchers to infer that Mamenchisaurus likely engaged in feeding at lower levels. Additionally, the presence of long overlapping cervical ribs may have constrained flexibility. The researchers also assessed the stress on the intervertebral joint cartilage, concluding that the neck was predominantly maintained in a straight position, with exceptions noted at the base and near the head. Mamenchisaurus is occasionally labeled as a wastebasket taxon, leading researchers to scrutinize the variety of species and incomplete remains attributed to this genus. The definition of the genus is vague, resulting in a complicated taxonomy that complicates the comprehension of its phylogenetic relationships. Numerous studies have not demonstrated that Mamenchisaurus is monophyletic, indicating a potential necessity for a re-evaluation of the genus. Further investigation into the type species, Mamenchisaurus youngi, is essential for a clearer understanding of the genus. Fossils of Mamenchisaurus have been found in China, but more specifically Chongqing, Sichuan, and Xinjiang provinces. Mamenchisaurus translates to Mamenchi lizard. The name is derived from the Chinese pinyin, where mi means horse and men signifies gate. Additionally, Che serves as an alternative transliteration of 11, which means stream or brook. The term concludes with the suffix saurus, originating from the Greek word sauros, meaning lizard. Mamenchisaurus utilized a range of self-defense strategies. Its impressive size and elongated neck likely served to discourage potential threats, while its tendency to form herds may have enhanced safety through collective behavior. Additionally, its powerful limbs and sturdy physique could have been effective in repelling any attackers when required. Madagascar, 16 million years ago. At present, we find ourselves in spring during the dry season. Certain desert plants remain dormant beneath the soil, and with the arrival of the wet season's rains, they emerge in the subsequent spring. Majungasaurus, a carnivorous abelisaurid. Majungasaurus was a theropod of moderate size, generally measuring between 18 and 23 feet long and weighing between 1,650 and 2,430 pounds. Evidence from incomplete remains suggests that some larger specimens may have approached the size of its relative, Carnotaurus, which could potentially have surpassed 26 feet in length. The skeletal structure of Majungasaurus, particularly its hand and finger bones, exhibited a notable absence of the typical pits and grooves associated with claw and tendon attachment, a feature common in other Majungasaurines. Additionally, the finger bones were fused, suggesting a lack of mobility in the hand. A more comprehensive specimen was analyzed in 2012, revealing that the lower arm was sturdy yet short, and the hand comprised four metatarsals along with four fingers that were likely very reduced and inflexible, potentially lacking claws altogether. Majungasaurus may have been better suited for a feeding strategy akin to that of contemporary pantherines, characterized by short and broad snouts that allow for a single, powerful bite followed by a firm grip until the prey is subdued. Notably, Majungasaurus possessed an even wider snout compared to other abelisaurids, and various anatomical features may lend credence to the bite and hold theory. Its neck exhibited significant strength, featuring robust vertebrae, interlocking ribs, and ossified tendons, along with reinforced sites for muscle attachment on both the vertebrae and the back of the skull. These muscular adaptations would have enabled it to maintain a steady head position, even in the face of its prey's struggles. A Majungasaurus has found a dead individual, providing a food source. Tooth-marked bones have been discovered on some Majungasaurus fossils, matching the size and spacing of Majungasaurus teeth. This suggests it likely preyed on its own species, as it is the only large theropod identified in the area. Majungasaurus fossils have been found in the province de Mahawanga in Madagascar. The vertebrae of Majungasaurus suggest the existence of air sacs. These air sacs could have facilitated a rudimentary version of avian-like flow-through ventilation, enabling a unidirectional airflow through the lungs. In this system, oxygen-rich air drawn in from the environment does not mix with the carbon dioxide-rich air that is exhaled. Although this respiratory method is complex, it is remarkably efficient. The skull of Majungasaurus, particularly the jugal, postorbital, and quadratojugal regions, appears to have developed increased height and robustness. Furthermore, there is evidence of greater fusion among the skull bones, accompanied by a relative reduction in the size of the eye sockets. These changes suggest a transition in dietary habits as the species matures from juvenile to adult stages.